So we have
Yeah.
collected a few questions, and are we going to have any slides before, Francisco?
Yeah. Would either of
I'm
you
not
like
prepared.
to? Oh, okay.
I've not prepared anything. As I
Okay.
mentioned, I'm on vacation. It's been really hectic. But I think what probably Robert and I could do is just say a few words, very spontaneous and improvised over what it was like to be on the OTP team and why the OTP project was started in the first place. And and just maybe share some memories from those times, and then from there move on to questions. How does that sound?
That sounds great.
Interesting.
I mean,
Wow.
Yeah, if Robert, you can also chip in, and I mean that'd be amazing to hear you both talk about that.
Sorry?
I had no idea, I had no idea that what we were working on would be, that influential and critical. And it took me a few years to realize that as well. So,
yeah, we were always. I mean, when the Erlang was developed, or the ideas behind it, the original language was developed, there were a lot of other development projects going on at Ericsson at the same time for languages and systems and things like this. So we were one of the ones that was being done, and well, we happened to survive basically. I mean, we got support from the right people and some early projects using it that worked.
We were best. We're the best.
Yeah, well,
something so Swedish.
Like
you are allowed to boast. Yeah, Swedes never boast, and that's a problem. But yeah,
yeah, we were, and it worked actually without boasting. Our our ideas worked, right? And you could build things with them that actually worked as well too. But it wasn't trivial getting there. I mean, it took us a number of years actually.
Yeah. And I think one of the main lessons is that it's not just about technology.
No,
it's just as much about relationships and politics as it is about. It's a VHS versus Betamax. War. Whoever has the biggest marketing budget and glossiest brochures often wins. But technically we were best. So.
But yeah, as I said, well, as we both said, that there were other projects going on, and there were other groups supporting those and things like this. But we had some very influential people in upper management who liked our ideas and supported us, which meant that the project could keep going while we're doing the development work, and eventually arrive at something which was practically usable in real projects. And then when people started using that, they showed that these ideas actually worked. They were comparatively efficient to implement and to build systems on and things like this compared to the more traditional versions. And as I said, there came a number of successful projects on top of that. And that's always a very good selling point, right? Having something that's worked, it's in use, things like this. But as Francesco said, it wasn't a purely technical battle in that sense. I mean, it was technical in the sense of working out a technology that was good. That wasn't trivial in itself, but then the political side was much more difficult. I was not part of that. I'm not good at that. So yes, that bit I don't know. But yeah, then it kept going, and then what Francesco came in the OTP team was what that was developed for. I mean, we had the base language and the base ideas, but you do need a set of libraries and ideas. What do I say?
You need
ideas. Yeah, go.
Yeah, you need libraries, you need training courses, you need consultancy, you need books. I think to quote Bjarne, I think Joe was the one who came up with the idea of a language, but also came up with the idea of writing a book. And that's really what gave, I think, Erlang a lot of its credibility in the early days. Having a book which others could go in and use.
Yeah. It was a bit weird.
I mean,
so you could go out and buy a book about Erlang, It was a real book. I mean, Apprentice Hall. I mean, proper publisher, but it could be very difficult to get hold of the Erlang system because it was still very proprietary Ericsson, and they were releasing only to select groups, right? So it's quite strange, actually.
I'm opening Zoom from my laptop as well, so I'm connecting from two ends. We'll keep the camera off and muted, but at least gives me access to the chat. Yeah. By the way, so yeah.
Oh yeah, there's the chat. And yeah, you're getting back to chat. Yes, basically we developed everything from scratch. A lot of ideas we took from other places. We were quite happy stealing ideas, right? There was no big deal about that.
It's called recycling, Robert. Not stealing, it's recycling ideas. It's a Swedish environmentally friendly ethos you had.
Which artist was it said that great artist steal? Wait.
That was me, sorry. Muted now.
Yeah, okay. Which artist said that great artists steal? Right. So we class ourselves under the great artist part. Picasso, I think, said that. But yeah, and yeah. So I mean, there are a lot of ideas out there. We took them. Been other attempts at writing languages, at Ericsson as well too. And I mean, if you look at our Erlang processes, they're quite close conceptually to operating system processes. So we thought that was a good idea. Why not use them? I mean, well, use that idea at least anyway, right? For it. The operating system processes are way too heavy, but you have the basic concepts there, so use them. We didn't invent functional languages. It worked. We sort of arrived at functional languages rather than having that as a target, but it worked and fitted together with everything else we were doing. I would say this is my personal opinion, but I think the most thing we probably invented, if anything, was the error handling mechanism with the links and the exit signals and things like this for it. And then being able to crash it. And I think that was something we evolved, developed while we were thinking about the language system. I can say quickie here, but we had a very close contact with another group outside the lab, where the computer science lab where this work was done. They were doing a research into new architecture for small systems. I don't know how we got talking to them at all, but that was a very useful collaboration because we had our ideas how you build these things, right? And we built and they would then test these ideas for looking for their own use as well too. But they'll then come back with comments and saying, did this idea work or not? Was it any good? I mean, sometimes we came up with bad ideas, right? And they just said, well, no. So basically we got rid of them, right? Sometimes we came up with a fantastic idea, which they said, yes, but we can't use it anyway. So we got rid of that as well too. So.
It's fascinating. You spoke to Joe, you speak to Mike Williams, you speak to Robert Verding, and you ask them individually, what influenced, these ideas which got you to where you are, but also what was your main contribution? And, speaking about bad ideas, I always smile at Mike Williams, who said, I spent most of my time convincing Joe and Robert that we actually didn't need this feature in the language because it was a great feature, but it just didn't add anything. It was just elegant. And Robert likes elegance versus, versus things which are actually useful. And that's where I think Mike, Joe, and Robert together were a fantastic team.
Yeah. Separately, we would not have arrived at something as good. Definitely. I mean, we just had different ideas, and I mean, it took a couple of years. And a lot of that time was arguing, discussing. They were arguing, depending how you want to say it, between the group, saying whether this was good, how should we do this or not do this. I still remember arguments, discussions, lunchtime with Joe of what you should do if you send a message to a process that's died. Should it go away as it does now, or should you get a signal back saying sort of no such send, no such zone type thing? And we had the discussion went backwards and forwards a long time before we decided where we end up.
And you decided you decided absolutely on the right thing, because then this approach is extendable to distribution. Had you sent back a signal saying, hey, the message didn't arrive, you wouldn't have been able to use the same syntax for distribution and semantics for distribution. It's I wish these arguments had been recorded, because understanding how you came to a particular conclusion.
I think, we did have a lot of thoughts about distribution while we're building the system, because we realized if you want to build a truly fault-tolerant system, you need at least 2 computers. You just can't get around that.
It's 3 if you ask Leslie Lamport.
Well, 3, okay. But at least 2, I said.
At least 2, yes.
Yes.
So
but sorry,
the famous slogan, "Let it crash." I saw it on T-shirt of Francesco. So how did this slogan come up? It's very interesting.
Let me see if I've got that T-shirt. I'll be out in a sec. 1 second.
Okay. No, the idea was that we were thinking very process-based, very lightweight processors. You can have lots of them, right? Compared to operating system processors, which are comparatively very heavy. So if you're going to do something, in our case, a call, you would probably have a lot of processes working. Now, you might have 5 or 6 or 7 processes on one call, each one doing different things and communicating with the other ones. This might sound more complex, but it makes each process much simpler. Then you get the situation, what happens if one of them goes wrong? Gets an error, right? And so one way of doing this is trying to clean up each process and cleaning up all the other processes in the system and or working together and so on. But that can get quite complex to do that. So our idea was, we're using the links, you just let the process that went wrong crash. Then it'd be linked to all the other processes taking part in that, and they would also crash. Right? And that's the let it crash philosophy for it, right? And so, of course, you have to monitor these and keep track of them. So when this group set of processes crash, you clean up afterwards, et cetera, et cetera. But the idea is, by doing it this way, you can't let things crash.
I think, mind you, if I'll hop in here a second, Robert, just to add to what you're saying, but the biggest problem with let it crash is that people, crash has a negative connotation. All let it crash means is that you take care of your errors. You still take care of your errors, but you take care of them in a different way than what you might be used to with imperative programming or sequential programming languages. And I think this is a big misunderstanding which exists out there, but it's you still handle your errors. You just handle them differently.
Yeah. Oh yeah, definitely. I mean, you can't, this is not ignoring errors. It's just a different way of doing it and saying, okay, I might have 5 processes working together. If one goes wrong, we'll take them all down. Someone will detect this, or other processes will detect this and clean up afterwards or start up things afterwards. So you're handling the errors, but you're handling them in a different way. I remember a very funny thing about that. There was a discussion in Stack Overflow many years ago about this. One guy was getting extremely worked up about the Erlang let it crash philosophy because he had misunderstood it. Well, no one explained it properly to him that he was thinking you crash the whole system, which we decided definitely actually the opposite we're doing. So he's getting very worked up about this. How can you let it crash? Because every time my system crashes, it costs me a few $100,000. So how can I let things crash? Right? And that's the thing. Getting back to what Francesco is saying here, you can let bits of it crash because the system is designed in such a way it will handle that and know what to do and keep going and clean up, etc., etc., etc. So it's an awful lot of thinking about how you architecture your system to do that. But when you can do that, then you can let things crash.
So, Sander, should we start, or well, we have in a way already started.
Yeah. So
we are starting. Yeah.
Yeah.
Go
So
ahead,
we have one more question. We would like to know about the story how Erlang crossed roads with actor models.
Yeah, there's a beautiful video I'm going to share with you. I'll post a link and you can watch it after. Go ahead, Robert. You answer this question. I don't think I was even born at the time. Yeah.
We didn't know about actors. At least I did not know about actors. Okay, so we found, well, again, this is my I can't remember what Joe and Mike knew about this, but I did not know about actors until afterwards. I started reading a few reports saying Erlang implemented the actor model. Then you go out and start reading what is the actor model, and you find, yeah, well, we have, but we did not know that. We basically arrived at very much the same thing from two different paths.
So
and,
it was, oh, sorry, go ahead, Robert. Go ahead, yeah.
Wait, I have to close the window because there are helicopters and stuff outside.
Okay, so I'll just add, I had the good fortune, and it's something I'd been wanting to do for a long time, of getting together Joe Armstrong, Carl Hewitt, and Sir Tony Hoare, and have them discuss, their ideas, because they came up with fairly similar ideas and concepts. And what I was trying to ask them is, what problem were you trying to solve? What problem were you trying to solve? And I was just, so I managed to get them, I think 3 years ago in Cambridge. It was actually the year before Joe passed away. So it was 2018 in Cambridge, at the university where Tony Hoare is a professor. And the question I asked him was, what problem were you trying to solve where you invented Erlang style concurrency, the actor model, and CSP respectively? And what the answer they gave me just blew me away, because Joe Armstrong replied, oh, we're trying to understand how to create fault tolerant systems. And in fact, you need, for fault tolerant systems, you need two of everything, because you need one actor to monitor the other actor. So you need at least two of everything. And it's not just computers, but it's also processes. Carl Hewitt was, I was trying to figure out how to program, I was trying to figure out programming models for distributed systems. And Tony Hoare, I was trying to figure out how to program transputers, which is basically today's multi-core architectures. But this was back in the 80s. And so basically the three problems which are very much tied together was concurrent programming, it was distributed programming, it was fault tolerant, so resilience, and parallelism. And all of these things, concurrency, no shared memory concurrency and distribution together give you scalability, which no one mentioned, interestingly enough. Well, Carl Hewitt started mentioning it. They give you scalability and they give you resilience. And then add multi-core architecture together with that, and you get parallelism. But everything is very much kind of united in a way. Let me try to share the screen. Are we allowed to share screens here? No, probably not. But yeah. So the three things hang together. And so what Robert was trying to do, Robert, Mike, and Joe was trying to do, they were solving a subset of it. They were looking at fault tolerance. I don't think scalability was in the back of your minds at the time, was it?
It was concurrency and fault tolerance. It was, that was it, right? That was it. I think we just thought scalability is self-evident, right? I don't have to think about scale. Of course I want scalable systems. I mean, why talk about it? Of course you want this, right? And we just didn't think about it in that sense explicitly.
And Carl Hewitt wasn't either, but he ended up in the end, in the end today, he's working on massively scalable systems.
Yes, he's talking millions of cores.
Yeah, exactly.
Yeah. Well, it was funny because I met Carl Hewitt earlier this year. It was in January, before, actually in San Francisco, before the all the lockdown stuff got going. And I was talking a bit about this, and I said, well, I'll sort of apologize a bit because that we had come up with, we didn't know, well, at least I didn't know about actors when we started working. And he said, well, he felt that this was a very good thing, actually, because we'd arrived at something very similar from two different ways. He came from a much more theoretical side, and we came from a very practical side. We arrived at this as a work type thing, and I thought this was a way of showing the power of that model. It was both theoretically nice and practically nice as well too. So yeah. Did you find your Let It Crash t-shirt, Francesco?
No, I've got it back in London.
Okay.
Was it
I have
you who
Unfortunately not.
Who wore that on an airplane?
Yes, I keep on forgetting, and I keep on wearing it when I fly, which, considering all of the terrorist actions, it's not. So I've posted 2 links in the chat, and keep in mind the chat might disappear after you log off. But one of them is the interview with, or the panel discussion between between Joe, Carl, and Tony, and which we recorded in Cambridge, and I really recommend everyone look at it. It's fascinating. Everyone seemed to agree on absolutely everything except for one is latency. Carl Hewitt seems to be very much focused on the importance of latency, and that's reflecting the problems he's trying to solve today, which is scalable intelligent agents versus, and then everyone disagreed with Tony Hoare, but did it so in a very respectable way over the need of synchronous message passing. Where for Tony Hoare it was good enough, it was solved his problem, but it didn't solve everyone else's problem. And so those were the 2 major disagreements. Else everyone absolutely agreed. They all agreed with it.
Yeah.
So.
And I agree. I mean, I've watched that interview like multiple times already, and I mean, I think that was probably one of the best videos I've seen, especially including the 3 of them and the discussion. I mean, it was it give everyone a lot to think about. I mean, anyone who was watching the interview, I mean, it's very insightful. Just on a side note, Robert, I'm just curious about the poster behind you. I mean, I couldn't stop noticing it. Yeah.
Okay, so what we did, I don't know if we're still going to do it. Are we do it? Well, it's a bit difficult to do it now, but for the Erlang User Conference, which was a traditional conference held every year in Stockholm, I think after Erlang Solutions took over managing that from Ericsson, someone came up with a very good idea that you take a poster from a movie and drop Joe, was it your fault? Okay. Drop Joe, Mike, and Diana into that in various situations, right? And that's one of them. Yeah.
They also did Sex and the City, but I luckily, which included me as well. It was just 4 of them. It included me as well. And luckily I managed to put a stop to that.
That was done. But these we actually, we prepared a number and had them up at the conference. We did one.
Harry Potter was the very first one. What we did is when Erlang Solutions took over the running of the Erlang User Conference, what we did is we moved the conference from the Ericsson premises to an old retro cinema in Stockholm. And so a really kind of 1970s cinema. It was gorgeous, absolutely gorgeous, which kind of fitted in with the Erlang style. And outside, you used to have the screens where you show, what film was playing. And so we had the Erlang the movie posters up with, and the very first one was Harry Potter. And you actually seen, how badly photoshopped the Harry Potter poster is versus, and then we got better at it as time went on. But it was, it put a smile on everyone's faces. And we still do it occasionally, but it's...
Some of them are really good.
Yeah, I mean, I'd like to see some more. I mean, I wouldn't mind purchasing a few and hanging them up on my wall here.
There was a problem that, I mean, people said, "Oh, could we buy a copy? Could we buy one?" And the answer was no, because we did not have any rights from the movie company.
So what happened is, we just went ahead and did it, and movie companies are then allowed to sue. But they're only allowed to sue for whatever profit you've made, and we've made no profit out of it. So, they could sue for 0 crowns, which basically meant that it was not worth it. So we kept it on a very, very low. Occasionally, we give them out as prizes, and we've given them out as prizes, or for those attending conferences.
Yeah.
So
we've
done that.
Is one that hung in our office, and when we moved office, I took it. I have a bunch of other ones somewhere as well too, small A4 size, but yes, that's good. I mean, some of them are really good. Some of them are really good. But yeah, that's the
Yeah.
picture.
It's
Wait.
Sure.
Not going to crash it now.
Aniruddha, can you please take the question after this one?
Sure.
Let's see, get a bit more out of it here. That's
You see how badly Joe's photoshopped it. What we did also, we took the we took the faces from Erlang the movie whenever it was possible. But
yeah.
If you notice, in Erlang the movie, Robert avoids looking straight at the camera, so he was really, really hard. So we had to get a co-conspirator into it, and his lovely wife helped us, find a picture of Robert as a youngster. so Elizabeth, was part of the plot there.
Even so,
yeah, the movie is all about Joe and Mike talking with each other, and I'm sitting there fixing the bugs, right? So you see my screen more than you see me. So yes, but that was also a bit of a joke, the movie.
What gave you the idea to make the movie? Just curious.
I don't know. I think it was somewhere up in marketing or something like this. I don't know who came up with the idea. That was way before Francesco.
That was way before me, but having heard the story, I think from Bjarne or someone or Joe someone at the lab had been given a video camera for Christmas. Those were the times of the great, the big VHS video cameras. And they walked into Bjarne's office and said, "Oh, we're gonna do a movie. I have a video camera now. We're gonna do a movie to help market Erlang with an Ericsson." And Bjarne there managed to steer it away from them doing it, and I think managed to get a professional crew on board to actually do it. Despite it was supposed to be completely serious, and it's been done professionally as well.
That's great.
But then the company that did it added this thing at the end where you see, I can't remember the name of the guy in the photograph there.
Agner Kara.
Sorry? Was it Kara? Yeah, it was Kara. Yes. Yeah, where he was, and this little tacky music at the end as well too. So
yeah, try it, you'll like it.
Yes. Yeah. But no, it was fun doing it though. The thing I liked the best was where we're sitting there was partially I don't know, wouldn't really call it a factory, but in one of the rooms you could lift up sections of the floor. Yeah. They could run things underneath the floor. And there's a picture in the movie where Mike is standing pointing to a small business exchange. Now that exchange is a bit less than a meter high, right? So he wouldn't have to stand and point down like this. They removed a section of the floor, and he stood underneath that, and he could point out to the right for that.
And he's short to start off with, so.
Mike short to start off with, yes. So that was very fun. Sorry, just wondering.
Okay, so we have a few
to join us actually. Not thinking of it. Too bad. Yeah.
So Aniruddha, can you please take your first question?
Yeah, so we'll just enter into a few technical questions, or we'll bounce around from here and there. So let me start off. One of the questions that we got from the audience some time ago actually was, nowadays more and more programming languages like Crystal, Go, Node, Python, using async-await, are adapting what's called cooperative scheduling compared to what Erlang uses, which I guess is preemptive scheduling, right? So what's your take on that? And what's your take on like cooperative versus preemptive scheduling?
So I think it's and I'll leave it over to Robert afterwards. Sorry if I interject, but this is really I think it's a big selling point. Cooperative scheduling, you actually leave the responsibility in the hands of the programmer. And that is extremely dangerous because it's extremely dangerous and it can really affect the software properties of your system. And that said, it might be ideal for certain types of problems, but definitely not the type of problem we're using Erlang and Elixir and any other language on the Beam for. And I'll steal Joe Armstrong's favorite example here. You know, assume you've got a system written in Node, and you go in and you send it a request to tell you if a number you're sending to it is a prime number. And then you ask, you know, tens of thousands of users to all go in and send, you know, the request with prime numbers. You know, amongst these tens of thousands of users, you know, most of them will be sending you small, medium-sized numbers, which is fine. You know, the node system, extremely fast, extremely powerful. Go in, munch it up, you know, and figure out, is it a prime number or not? And then you've got the smartass in the whole crowd, which goes in and sends a huge number. And what this does is it blocks all the other tens of thousands of users and keeps them waiting for, you know, this huge number, you know, to figure out if it's a prime number or not. And that basically, you know, creates starvation across all these other systems at a cost which, you know, you probably wouldn't have found out or figured out in a test plan, which you end up, you know, paying for in a live system. And that's the real reason for it. You know, all these other users, all of a sudden, yeah, even though they've got small numbers, they have to wait for this huge number to execute, finish completion, to complete. And that is the reason why, yeah, you know, for soft real-time systems, for large, massively scalable soft real-time systems, you need preemptive scheduling. Just take the JVM, where you've got the 1 percentile of all of the users, which, you know, happen to be running right when the garbage collector kicks in. The latency spikes all of a sudden. And again,
true.
That's definitely. I mean, you can't trust the user. It's the same thing. No. Why do we provide memory management?
You can't trust a user. You can't trust a programmer. You can't trust a programmer.
No, but if you've ever done serious memory management yourself, it is so easy to make a mistake. It's the same thing with the concurrency. It's so easy. I just forget to hand over sometime control to another process or another task, whatever you want to call it. I just forget to do that, and suddenly I'm blocking the whole system. And you have to think about it. Much better have the system do it for you. Yeah. And it works. And you can see, well, that's not a bit of boasting. You can see a bit if you look at statistics, timings and measurements for Erlang systems, you'll find that the latency is much more even than in many other systems work, just because the system does it for you.
And whilst we have priorities in Erlang, the advice is don't use them, because it will end up backfiring.
Oh yeah. Never use the priorities. No. You shouldn't use them. They work, of course.
No, but they work, but yeah, but it will backfire. There will be cases where it will backfire and you won't get the intended behavior. And that has to do with queue theory more than anything. And, you know, how many of you have studied queue theory, you know, and have a PhD in it? I can assure you no one's raising their hand, including me and Robert. And it's, you know, if, you know, and what you're doing is, you know, we know that, you know, if especially with premature optimizations, you know, you'll end up shooting yourself in the foot. And that's exactly what you want to try to avoid.
Yeah, but in what circumstances would you actually use the priorities? I'm just, you know, like, I know this is a very limited use case, but like, you know, in what situations would you actually do that?
There are a few cases internally in the OTP library, some parts of the OTP library, there are very few where you want to make sure, I want to do a sequence of things, A, B, and C, and I want to make sure that my process is not scheduled out in that sequence.
Yeah.
Then you say, okay, I give myself maximum priority, I do my 3 things, then I put myself down to normal priority. But then it's up to me to make sure, one, I'm doing it in the right place, and that I don't forget to lower the priorities or something like this for it and start blocking the system. But there are a few cases where you need to do that. I've seen, I can't remember what they were, but I have seen it.
Yeah. And what you do is you learn to work your way around priorities, optimizing your concurrency in a way that you don't need them. And so it's almost like, you know, you avoid priorities by design, and you know, by design of your system. And
well, another thing is, I have a high priority process, and I send a message to another process. Now, what happens if that process is a normal priority? Well, I still have to sit and wait for it in a normal sense and things like this for it. So once you start getting the concurrency in it,
and this is a complete example. Said it backfires. Often backfires. This is a typical example of when it does backfire.
The other circumstance is that you can probably have a lot of processes saying that no, I'm a higher priority process. I mean, I want to be. So you can have a lot of situations like that where it just kind of backs up the whole system.
When things go multi-core, I mean, if I'm running 16 things at the same time and one's high priority, then I'm only using a little bit of the system anyway, right? Because I can't block the other things. It tends to break down in a sense. As Francesco was saying, you just have to you have to rethink how you structure your system to get around these things. And
the difference between like cooperative and primitive, like primitive, that I got the question because like in some of the reviews I saw like Golang, like basically it splits the job, like before running it inserts the yields in between, and so by default, like all the, like if a program or snippet is blocking, and it should not cause it should not block the other things, so it inserts some yield in between. So so in that sense, like do you think like the preemptive scheduling is more advantageous like compared to others?
What you just described is preemptive scheduling, though. I believe Golang has preemptive scheduling with its Go routines.
Okay, then.
So that's my view. I mean, Golang has other issues with its concurrency, but scheduling is definitely, as far as I'm aware, not one of them. I mean, Robert, are you?
I've only played a bit with Golang, so I haven't really seriously looked at it.
Yeah,
but
I mean, these challenges start coming up and these issues start coming up when you start using it in anger at a scale. And indeed, I've never heard this being an issue in Golang. The real issue with Golang is lack of error semantics in the language. You know, you can have a Go routine terminate and crash, and you've got no idea it's crashed. And that is, I think, a big flaw. You know, when comparing it to Erlang, so you might get speed, but you don't get the full tolerance having Erlang. So the whole kind of let it crash philosophy can't be applied to it, and that in turn results in an extra layer of complexity which needs to be added to deal with all of the error.
And programming error handling is the right pain.
Yeah, we can't even watch monitor the process and monitor the Go routine in Golang. Yeah, that is one very good thing in Erlang. So we can even understand one individual process, and so we can monitor them.
I mean that was one of the core requirements, base requirements we had from the very beginning, that the system has default tolerance. Worst thing that can happen is the whole system crashes. Well, that's the second worst thing that can happen. The worst thing that happens is the computer dies, right? But if our system dies, that's the worst thing that could happen. So things are going to go wrong. How do you how can I give support building a system that can handle things going wrong in such a way that the system does not die, but can catch these things, detect them, clean up afterwards, and keep going? So from our point of view, telecoms, yes, we might lose a call, but other calls will still keep going, and the system will still keep going for it. And losing a call, of course, is not good, but as long as the system keeps going, it's acceptable.
Yeah.
And we explained all of the error handling semantics to Ken Thompson and the rest of the Go team. It was Joe who explained it. I think it was probably 6-7 years ago. The real challenge there, though, is that I don't think those were not the types of system the team was used to implementing. And so, you know, you can explain something, but if they've not experienced this challenge, and if that's not the problem they were trying to solve, then you know, it's hard, you know, to get it. And so, you know, as a result, 7 years on, those error semantics still haven't been added to Go. That said, I did ask him, what problem were you trying to solve when you invented Go? Because I'm a firm believer that every programming language, which is invented, needs to be, you need to go out and solve a particular problem. And and because at least you've got a goal, you've got a focus, you've got proof of concepts, you can go in and execute. And the problem the Go team decided to try to solve was implementing a better C. So they were aiming at speed, but without the constraints of memory management, with automated memory handling, and that's still today. That's where I believe Go excels, and Go should be used.
And plus, I believe Go to some degree also borrowed from CSP and languages like that, right? I mean, I don't know for sure. I remember hearing this in an interview I think a year or two ago. But I think to some degree, some of the Go semantics or the internal design was basically somewhat based on CSP a little bit. I mean, it was an influence.
It was influenced by CSP more than by the active model. But I think if you ask Rod Pike, he'll say it's somewhere in between Erlang and CSP. I think there's an OSCON talk from Rod Pike in the emerging languages track. So Google Rod Pike emerging languages track OSCON, and you will find a YouTube video, and that's where he claims it leans more towards CSP. That's correct.
So I have a question regarding the design patterns. My name is Chaitanya. So most of the programming languages are dominated by the object-oriented design patterns. So if someone is looking at a functional programming, so what are the design patterns one can apply in his application or program? So can you please throw some light on that?
The object-oriented, generally speaking, don't fit very well. I mean, it depends which ones you're thinking about here, but I mean, we don't do shared, we don't do mutable, and we don't do global. And most of the object-oriented languages assume that in some way, those things for it. We just don't do that. That's just not part of our model. And that is why mapping object-oriented designs onto Erlang works. You can do it. I mean, it's not impossible, but it's not an efficient way of structuring the system. Okay. So if I want to do a shared global thing, at least we have something control over it, I have to put that in a process. Putting in an ETS table, that will work, but that also means anyone can read and write it. So I have to put it inside a process, and then I'm suddenly, I can make it something that looks like it's object-oriented, but it just behaves differently and different properties from a proper one, or from the classic object-oriented form.
And I think having taught Erlang for well over 20 years, a large part of teaching Erlang to developers is helping them unlearn their bad habits from other programming models. When you're approaching Erlang, you need to start thinking. So I think you need to start thinking the Erlang way and approaching it the Erlang way, and that way is not so much functional, but it's more concurrent. You need to start thinking concurrently. You need to start thinking processes over the fact that processes don't share memory and processes communicate with each other through message passing. I think that's the main, and there, from there, you start applying concurrent patterns, not functional ones. And the biggest challenge is, back in the days where people trying to implement, C++ in Erlang or implement Java in Erlang. Today we see it in Elixir, developers trying to write Ruby in Elixir. And it completely breaks the logic because they're different programming models, and so you need to program Elixir using an Erlang programming model. And I think this answers another question as to why I know Elixir. Why should I learn Erlang? But it's you need to start thinking concurrently and using Erlang style concurrency. start thinking in terms of, bottlenecks in your system, start thinking in terms of asynchronous versus asynchronous message passing, and in terms of supervision trees. And I think OTP is your design pattern. Start thinking in terms of OTP, what behaviors do you give your processes? What behaviors, how do you let them interact with each other? And how do you model them in hierarchies, supervision hierarchies, which ensure that you isolate errors? And it's not easy. It's a steep learning curve. But once, it's a learning curve you've got in any programming language. But, because of the fact that you're using, these approaches, this learning curve is much more upfront, because before, you really can claim you can master the language. Once you've done it, you've abstracted so much of all of the things which can go wrong, through the use of libraries, that your productivity is really enhanced. And I think there's a really good study from Heriot-Watt University in Edinburgh, which shows this. What they did is they took a C++ application which was live and running at Motorola, and re-implemented it in Erlang. And they went then and examined every single line of code, and came to the conclusion that if you assume that OTP is part of the standard libraries, the Erlang counterpart was 20 times less code than its counterpart in C++. And things such as error handling and defensive programming in C++, it was about 25% of the code base. In the Erlang version, it was 1% of the code base, because again, all of the error handling and defensive programming is moved over to the libraries. So but again, and that means 20 times less code. And we know from all other studies around programmer productivity that more or less it takes the same amount of time to write a line of Erlang as it does to write a line of Java, a line of Haskell, a line of Elixir. So time-wise is the same, but 20 times less code means a 20-fold increase in productivity. We also know that the bug density in software is in programming languages more or less the same per lines of code. Again, these are academic studies, and that means a 20-fold increase in quality as well, because you have 20 times less bugs if you have 20 times less code. So
I agree with that, and I don't know if you guys know this, but there was a mention earlier about how Erlang, in the way that it's designed, mirrors quite closely to operating systems, and that's why you use the semantics of processes and stuff like that. And so there actually is an operating system that has a similar internal structure to what we see in Erlang, in that if you guys know of Minix, the operating system made by Andrew Tannenbaum, it also has...
I've heard of it, but I haven't used it.
Yeah, so it also has these kinds of semantics internally. I mean, in terms of a supervisor, they have what's called a reincarnation server, but and internally it's all servers basically, but so it has the same way of working, in that all of the different processes, like the file system, the network drives and everything, they're all separate processes, and they run independently, and there's this reincarnation server that keeps pinging them every so often to see whether or not they're up. And if it doesn't get a response, it'll basically crash the server and then restart it again. And that way the entire system stays on, and can even not withstand particularly, but like it'll keep working even when you have an update that you need to install or something like that. So whereas normally with Windows or with Linux or whatever, you have to restart your entire operating system when like a system update comes in, or like something wants to, or like if they want to update the kernel or whatever. But here they implement in such a way that you can even update like the file system and have the operating system keep running even then. And to your point, Francesco, Andrew also made it a point to mention that
Right.
the amount of code that they wrote to implement this operating system was significantly low. Like somewhere in the order of like, I think 100,000 lines or maybe more or less. I could be wrong.
Yeah.
So go on.
It boils down to having the right semantics and the right ideas, and that's how you then simplify everything. Absolutely. Tannenbaum was a blast from the past. We used his book in my operating systems course. So
we do. We still do.
It doesn't surprise me because it's not much has changed. Their ideas to the right ones. So
Okay, so we have a few students who are in final year of college. They have asked us a question: how to get started with Elixir or Erlang? They are like students, college students. They are asking for a path.
So
how to learn it?
What would you recommend that you go into?
Okay. Well, now you're listening to sales Robert here. We give courses, right? I've done the sales bit. There are quite a few good books to get started with it. I think, there are a couple of good Erlang books.
Some great Elixir books as well.
But Learn Use of Erlang is a good book to start with. If you want to go further on, you've got Francesco's book, which goes much deeper into OTP. There are a number of good Elixir books as well too. In one way, it doesn't really matter which of the languages you choose, because semantically they're the same. They're the same language. There's two skins on top of the same thing. And they both use OTP.
Erlang is slightly simpler to learn.
It's a simpler syntax,
simpler syntax, and it's also simpler semantics. It doesn't have as many constructs as Elixir. But again, your Elixir is a bit more powerful, and it caters a bit more for kind of UI, UX, front-end development, especially the methodologies you use, the approaches you use, versus Erlang, which is much more suited for back-end systems, highly scalable, highly robust systems, where you often need to dig it straight into the code base. So it's very different use cases.
But you can start with one and migrate to the other if you wish, or something like this.
Okay. So that was for students, and if there are professionals who have used other languages like Java or Python, any similar languages for 2-3 years or maybe 5 years, for them, what is the path to learn Erlang and Elixir?
I would say, well, at least when giving courses, they'll run into two problems.
Let me add a point. They have used OOP, object-oriented, and not used functional language before.
So
forget that. Forget the OOP.
Yeah.
That's
you need to unlearn it. You need to unlearn it, and the best way is reading. Learn some Erlang, read Erlang programming, read programming Erlang. Those are the free textbooks, main textbooks, and they all explain how to think concurrently, but they do so in a different way. And and the three books are really complementary of each other. And I warmly recommend, reading all three of them, focusing on the sections on concurrency, because that is the core of Erlang. That's the main ideas. It's not functional, it's concurrency. The functional paradigm helps with the concurrency model, but it's concurrency. That's the main part. And having an editor, many of the books have exercises, doing those exercises, and also trying to solve problems which you've solved previously, but in Python, in Java, but doing so in Erlang. And if you're coming from a Ruby background or a JavaScript background or a UI UX background, don't go down the Erlang route, go down the Elixir route, because you'll find the language being much more approachable in terms of tool chains and tool sets which you're used to, in terms of package managers, in terms of top-down development and development methodologies, and you will find Elixir much more approachable from that perspective. And there, I think, again, great books, Sasa Uric, Elixir, OTP in Action is a must read for anyone, as well as, Dave Thomas's book and others. But what you will find with Dave Thomas's book and others is that concurrence is not at, not at the core. So what they'll do is, they'll describe a lot of other aspects, which, functional aspects and ideas and approaches, and then concurrence is in there, but it's not the core idea. And again, this is very much based on the fact that when you do using Elixir, you'll usually use frameworks. You most likely will use Phoenix, and so as a result, you don't need to understand the concurrency, because the concurrency is taken care of for you by the framework itself, and by the libraries you're using.
So are you saying to use learn Erlang before Elixir? If someone they do not know
completely depends on your background. It absolutely completely depends on your background. If you're used to Python, if you're used to Java and you're doing backend systems, server-side systems, I would recommend going down the Erlang route. If you're if you're used to a bottom-up approach where you like solving difficult problems, where you first want to solve the problem and make sure it works before you start doing all of the glue, I'd suggest Erlang. If you are if you're coming from a JavaScript background, from a Ruby background, or a UI, UX, API, mobile app, create, read, update, delete background, definitely Elixir. Because the libraries and the frameworks you'll find will be much more familiar.
Okay, so if it's CRUD type, then jump for Elixir is suggested.
Elixir, absolutely. You will get lulled into this false sense of familiarity, and then
sure.
Yeah.
So we have a next question.
Barrier to entry. So Robert, you had something you wanted to add. Yeah.
Just a very quick comment about that. If you're coming from a Ruby background and going into Elixir, in many ways the syntax feels familiar, which is part of the design, but it is not Ruby. And they themselves, the developers, stress this. It might look Ruby-ish, but it is not Ruby. And you still have to do this rethink of how you work the language and how you build your system.
Yeah. Do not program Ruby in Elixir. There's no point. Stick to Ruby in that case. It's a great language. It's got joy of programming to millions of developers out there. Yes, stick to Ruby. You need to really understand concurrency.
So I have a couple of internal questions.
Can I just make a very quick comment to what someone wrote on the chat? It was Neil. Why not use S expressions? I was the only Lisp programmer for that of the three. The other people came from C and Fortran backgrounds, things like that. I was the only Lisp programmer in the group. And well, beyond a decade, he was as well too, but we never got that far. And the syntax evolved. It wasn't planned to look like this, it evolved, and that it just didn't do that. I much prefer S expressions. Lisp syntax is simpler, it's more consistent, it's better in every way, but we couldn't get it in. And considering the complaints we got about the Erlang syntax, having Lisp would have made S expression-based syntax would have made even more complaints. But it is much better. LFE.
Long live Lisp flavored Erlang, yes.
once you become a Lisp, you're a Lisp until you die, right? That's just. Sorry, quick. Okay, now get back to your question. Sorry.
Yeah, Robert and Francisco, I have a couple of questions probably related to the internals of the Erlang. Curious to know. So I wanted to understand how the preemptive scheduling works. Like exact question is how the dirty scheduling works. How does the determination of where to break for something that is loaded outside the Erlang ecosystem? That's one question. And another question is around the distribution. How do we handle signals or the linking across distributed nodes? Let's say processes are created in one node, which are linked to the local process on that node, and then the same function, anonymous function, is transferred to another node and executed over there. How does this linking work across nodes? These are two, I mean, I'm okay with a crisp answer on this. I would like to know these two things.
Robert, do you want to have a go?
Yeah. The scheduling, the preemptive scheduling is actually extremely simple. The basis of it, anyway, not the practical details, but the basis of it. It's counting function calls.
How do you apply it? I think the question is more, how do you apply it to dirty schedulers and to things outside of the ecosystem? Yeah.
Okay, so what happens? So in the Erlang side, it's just counting function calls, and everything is a function call. There are no loops, constructs, things like this. That makes it extremely simple. After so many function calls, the process is scheduled out. With dirty schedulers, so there's this concept of schedulers in the virtual machine. You have the normal schedulers running Erlang, and if you want to run, say, C code or something like that, if they can't be scheduled in the same way. Schedulers are run in operating system threads. So you will have a number of threads running the Erlang code, and you'll have a number of threads running dirty schedulers. And you can say when you're running my C code, I want this is dirty. Put this in a dirty scheduler. And the Erlang system does not try to schedule that. Then it's up to the operating system to handle threads. Because the very fact that it's dirty means we've handed over control. So
yeah, does that mean the Erlang process have to wait for the yield to happen from the C function that was getting executed over there?
Yeah. So what? Yes. So if you're running a dirty one, you will call that C function, and the Erlang process will sit and wait for the reply. That's the internal NIF handling, how this works. It will just sit and wait for the reply. So when I'm calling a C function from Erlang, it's calling a function. And so I'll call the function, I'll pass data in, then my call from the Erlang side will just sit and wait. That Erlang process will sit and wait. The Erlang scheduler will say, okay, I'm sitting and waiting here, so I'll run something else in the meantime. And when the reply comes back, then I'll reschedule that process. So we're not blocking the Erlang side.
Okay, so that means the whole job of running the entire C code is offloaded to the operating system for the management rather than Erlang actually trying to do better at it.
Yeah. And the logic there is, okay, once you're in the C code, you can write whatever you want.
Yeah.
So the Erlang trying to schedule that would be extremely difficult, if at all possible. So yeah.
Okay. So the next question I had, sorry. Yeah, go ahead.
I'm just saying you have threads running Erlang code, you have threads running C code or whatever other language it might be. And it's up to the operating system to schedule those.
Yes. The next question I had was, how does the process linking works across the distributed nodes? How does it work internally? So we know that a function can be like a closure can be sent across nodes and then gets executed over there and we get the response back. But let's say the closure also embeds a link to a locally running process, and if it's sent across nodes, how does that linking work across nodes, across the distributed nodes?
When you link to a process, you're linking to a process ID, a PID.
Right.
In that process ID, there's information on what node that process is on. Okay, whether it's my node or whether it's another node.
Okay.
And when I call the link built in, then the system, the base virtual machine, the beam will say, oh, this is a local one to set up a local link. This is a link to a process in another node. So it will set up contact with the other node if that is not running, and will keep track of the links from my node to the other node and backwards. And then it'll tell the other operating system, the other node, to say, okay, I have a link from a process on my node to a process on your node, and it will set up this information.
Okay.
So a process knows all the process it's linked to, and if something dies, we'll send signals to them, and if they're local, there'll be local signals. If they're remote, they'll be sent to the other node saying, okay, send this signal to that process coming from here, type thing.
Okay. So one last question I have around the same distribution. So that was around, let's say I take the EPMD as an independent, let's say, service, and then I try to implement the same EPMD for a language like Golang, or for a language like Java, which does not have distribution built into itself. by just following or adhering to the specification of APMT, what could be the challenges that we might not be able to implement in the new language? Something like a link is something I'm not sure how do you implement that, but other things, what other things can we think of?
One of the things with the Erlang distribution is that the nodes keep track of other nodes.
Right.
So if another node dies or we lose contact for it, I will find out about that, and then I might get great signals or what have you for it, and I can't send things to it, etc., for it. That's not really handled in the EPMD. All the EPMD really does, I think you have to correct me here, Francesco, but all the is for setting up connections to other nodes.
That is correct,
so
yes.
If I want to connect to node foo somewhere, I'll call my EPMD, which will talk to the EPMD on the machine I'm trying to talk to, and that EPMD will say, oh, I have a foo node here, and then we'll set up connection.
And what it does is it's a very simple, a bit of C code. And the reason it uses it is to avoid race conditions where, two nodes go in and try to connect to the same port. So it serializes all of the requests, when it comes to distribution, which have to be serialized, and acts basically centrally on behalf of all nodes on that particular machine. I think what you're thinking of here, I think all of the distributed operations actually go in and are managed by the net kernel. And it's a very, very simple piece of code, but which handles security, which handles your linking, and it handles all distributed message passing and the likes. And it's code which you can actually go in and modify yourself if you want to override it. And it's not that hard to understand. So I recommend you actually go in and start looking at the code implementation of the net kernel. Because that's where all of the distributed operations are actually replaced by messages which are sent to the net kernel and then sent across to the receiving node. And so there you can actually see how everything's been implemented. It's usually local constructs and then distributed across that way.
Okay. If I may ask another question, if Sandesh, do you want to remind the time? I have a general question to ask regarding the language by itself.
Sure.
So this is about, so are there some things, so right now the Erlang ecosystem or the runtime is quite stable in its own form, right? Whichever language it is written in, C or C++. But is there some benefit in rewriting that runtime in languages like Rustlang, which actually gives us more flexibility in terms of the fine-grained memory management, even at the language level itself, and also some of the memory safe guarantees that we get out of the box? Do you have any thoughts around that?
So I know there are a few virtual machines, which are written in Rust. I mean, Dmitry Litovchenko at Erlang Solution, sits in the same office as Robert, has written one or two there. If you look at the WASM implementation, which Dockyard is implementing, that's also Rust-based. And I think, to answer your question, it very much depends on what problem you're trying to solve. And when I talk about problem here is, what is your target environment? I think, hundreds of person years have gone into the Beam VM right now. A complete rewrite, I think, would be very, very painful. But, new rewrites, new targets, I mean, Rust makes perfect sense to me. Or even Go, use Go. They're trying to implement a better C. So
I was more worried about
targeting.
dual runtimes, because Go packages with its own runtime and Erlang on top of that also has a runtime. So I'm not sure if that fits well. That's why I was looking at Rustlang. I was just curious.
Exactly. And I've not seen anyone using Go, but I've seen, Rustlang is being used in multiple places. And I think it very much depends on what the target environment is, where you want to go for, and this level of memory management. Dimitro What was Robert? What was Dimitri's VM called? Do you remember? Could you Google it?
I can't remember.
If you could just Google it, yeah, and post a link. I don't. My laptop's down right now, so I'm connected via my phone. Okay. Sorry, yeah. But what Dimitri was, what he was using Rust for was actually aiming for embedded devices, which would have a much lower memory footprint. And I think that goes back to exactly what you're saying, where you've got such a level of granularity. And also, he was looking at a simple runtime. So he was a single core, running on a single core, and then running on a single core. So he was aiming at simplicity, aiming at a very compact VM, and at a very compact VM, which could run on small embedded devices. And that's the problem he was trying to solve. That was his target environment. Okay. And if you'll have multiple cores on embedded devices, well, you solve that by having 4 VMs running if you've got 4 cores, and each one running on a single on a core, and then you use distribution across the VMs to let them communicate. Your program will behave in exactly the same way as it would on the beam.
Yeah, got that.
I don't know if that answers your question.
Yeah, I kind of understood what you said. In a way, that all depends on what we are trying to solve. What is the platform we are trying to target? Yeah, so got it.
Yeah, exactly. I think it's very much use the right tool for the job, and I perfectly agree with you. Rust is the right tool for a lot of jobs.
Yeah, it's a nice T-shirt, React, Rob.
Rest in peace.
So one of the questions from audience was, what are the good open source repositories they can contribute to Erlang? Like React was there, like any more repositories they can contribute to?
Mongoose AM, if you're into instant messaging.
Okay.
That's just recently, I think, they posted new scaling, basically new benchmarks over scaling over millions of connected users, 45,000 messages per second throughput on a single node, linearly scalable. So that's one which I recommend. A very clean Erlang and Elixir code bases, all open source. They're actually now going to open source also the load testing tool, which they use for continuous load testing. Every time you submit pull request, it actually runs load tests.
Okay, so we have a couple of more questions. We just need to understand how much time can we have.
Yeah, are you guys...
I might have to turn off my camera and start chopping onions. I've got kids here and I need to cook lunch for them. But yes, but I can, if you don't mind me chopping onions whilst I speak, I have no issues continuing.
I don't have any problems either with time at the moment, so it's fine.
Yeah. Okay. All right. So one of the question is, like, are there any competitions to code in Beam and show your talent, and like advent of code, etc.?
Sorry, I didn't quite get that.
Yeah, Aniruddha, can you ask?
So, okay, well, just to reiterate Sandesh's question, basically, if, like how there are all these coding competitions that happen every so often. So, are there any that you know of for Erlang or, Erlang Elixir that you would like to plug? Or
Spawnfest. Spawnfest. If you could post a link to it, just Google it, Spawnfest, which is happening, I think, very soon. Really recommend it.
Yeah. Right. That's a big one. It's a big one every year. I've been a judge a couple of times, but this year it didn't work out. But yes, that's a good one.
So can we have any such competitions?
Start one. Happy to support it. Yeah. I warmly recommend it. Spawnfest is a great one, but I'm sure that doing it 2 times a year, it takes a lot of time to organize and coordinate. But it really helps. You put your name on the map, and it helps helps with your contact network because you're reaching out, to a lot of companies looking for sponsors. And Spawn Festival lasts 24 hours or 48. It lasts a whole weekend, so it's global. And there are people taking over from all parts of the world, participating from all parts of the world. And I really encourage you to do take similar initiatives as well. Another is the ICFP Functional Programming Competition, which I think has just happened now, where you can pick any language you want.
As long as it's more or less functional.
And they've used C as well. They've used C, and sometimes C was the right tool. Where you have a lot of cryptographic stuff. But yeah.
Yeah. No, we got away from writing everything in Erlang very early, actually.
Yeah.
So from that point of view, most systems you'll find Erlang or Elixir, if that matter, in you'll find that parts that are written in other languages, not just the VM. So if you need that, I don't see any problem doing that, or any philosophical problem doing that. If you have a package or something like that which does something you want in another language, then you can interface that to Erlang and use it from Erlang. You just have to get the interface nice, right, right level. Then do that, right?
Yeah. I know, Robert, you use Emacs editor.
Yeah, of course.
And about Francisco.
So do I. Emacs,
wow.
Emacs, absolutely.
Wow.
Yeah, but I think that very much kind of reflects when I started programming.
Yes.
I initially used VI and then moved over to Emacs. And I think it very much depends on what generation you're in. But luckily, there's very good support for most editors out there. And one of the lessons learned is don't try to inflict a particular language, a particular editor to someone. They will go in and let them pick what works best for them. And I think it's great to see work which is happening now with the Erlang language server, and even the integration in Visual Studio, and and all of the hard work IntelliJ has done. It's lack of IDEs was cited as one of the excuses for not adopting Erlang, because you could use any editor you wanted as long as it was Emacs. That's not the case anymore.
That's actually
Emacs is the best. I mean, there's no discussion. There's nothing you can't do in Emacs, right? There's an Emacs mode for everything, right?
And if there is no Emacs mode, you can write your own.
Well, we did. We wrote the Erlang mode for Emacs.
Okay.
So Anders Lindgren wrote it. Yeah.
And plus, it's a Lisp. I mean, that kind of adds to it.
Yeah.
So I have a question. Yeah, I have a question which is asked by a professor. They teach Erlang to their students. The question is, how do we separate concerns? Now, to explain like how to decide what OTP, what supervisor to make, what gen server to make. This is the question. I think this is what they are asking. The thought process, how to separate.
So Erlang processes are extremely general. You can do whatever you want in that. One of those. The OTP behaviors, they provide a set of predefined, design patterns. I mean, the gen server, it's a client server pattern it gives you. And which is very common, which fits very many things. You have the gen statem if you need a state machine, for example. And they're two different ones. The supervisors are very specific. They're just there for managing things. You can, it's practically impossible to get a supervisor process to do work. It's designed to do that by all. It's designed to start children and to keep track of the children. And if and when the children die, it knows what to do. That's really all the supervisor does. You need to keep this separation in mind. Even if, this is exactly the same if you're doing Elixir, you have exactly the same separation because it's based, the Elixir behaviors it provides with extra ones. They're built on top of the Erlang ones. They have exactly the same handling for it. Now, for example, Elixir might allow you to create a gen server and a supervisor together, but you still have the same idea. We have a supervisor managing the gen server at the bottom, keeping track of that. So you have to be very aware of what you're doing. You have to be very aware of when I create a gen server, I am creating another process. It's not an object. So when I send things to it, I'm actually sending things to it. I'm sending, when I do a gen server call, I'm sending a request to that gen server process and then getting a reply back and returning it. It's not like it doesn't behave like an object. Although the interface might look objecty, but it doesn't behave in that sense. I think that's the way of doing it. You're using OTP, you're still building the whole the system of with concurrency and all those type of things and connections between the concurrency. The OTP is just providing you with a nice layer on top. And that layer, most of the time, you can use. I mean, what Elixir have done, they've added a few extra behaviors to this, but they're still having the same ideas. That just gets on to one thing I want to say. OTP, in Erlang, you have 5 behaviors. Elixir, I think, have 7 or something like this. You can add your own behaviors if you want to. It's not locked. It's not sort of in a brick wall or something like that. It's extensible. Elixir have done that. You can do that yourself in Erlang or Elixir if you need to. But get the fact what you're doing and the fact that you are actually using the concurrency in the system.
Yeah. So
is not an object.
I just wanted to add to what Robert is saying. There's a brilliant quote by Joel Spolsky, which is, programming consists of overcoming 2 things: accidental difficulties, which are basically things which are difficult because you happen to be using an inadequate programming tools, and things which are actually difficult, which no programming tool or language is going to solve. And so what these abstractions, Robert just described, remove a lot of the accidental difficulties, and it actually allows you to focus on the hard problems, on the problem, on the business logic which your system is supposed to solve. And that's really where you go in and you get a lot of power into it. Now, what Robert has discussed here is very much kind of the programming model which you'd be using. But if you look at the abstraction layers, I think you've got many more abstraction layers. You've got the network, which in some way you want to abstract. You've got the operating system, which you want to standardize and abstract. You've got the virtual machine, which you want to abstract. And then you've got the distribution layer, which you want to abstract. And you've got the programming language on top of it, which you want to abstract. And finally, you've got the programming model. So, we've just covered the tip of the iceberg here. And if you look at, what the future holds, hopefully it will be, more standardizations across programming languages, across distributed topologies, virtual machines, operating systems, and networks, so that they can be interchanged without you having to change or swap your programs. So, what you've written, could run on a single Beam node, but then, you could easily just pick it up and run it on, 4 nodes running a Rust VM in an embedded environment. And so, these abstraction layers are really, really critical. And I don't think we think enough. We don't abstract enough in our programming languages, in our designs. And that's why we've got very few reusable components. I think, someone mentioned, the React, React Core. React on my, Sanders mentioned React on my t-shirt. Well, React Core is a brilliant distributed framework, but it only works for Erlang. It only works for consistent hashing, and it only works with a Dynamo style, topology. And so whatever code you write on it will have to be, the business logic will have to be, tied integrated with this type of mindset and approach. But what if you could instead write business logic, which solves a particular problem, and then replaced the Dynamo principle with a fully meshed, distributed approach, or a distributed, or a peer-to-peer approach, for example. and without changing a single line of your code. And I think that's really where what I believe the future holds for us.
Yeah, actually on that, I was just wondering, like, what would inform your design of your application? Because I mean, especially when it comes to someone who's starting out, obviously there's a lot of material that one doesn't really know that much about. You know, it kind of learn a lot about these things before you kind of use those specific patterns or tools that are available by the language. Like when you go about trying to create a solution to your problem using Erlang, like what would typically inform your design? And I mean, or you know, would it be that only someone who's been using the language for a long time and is fairly familiar with a lot of its idioms and design patterns, you know, where only them go on? You know.
So it took me, I recommend designing for scalability, which I wrote. And the last chapter of that book was supposed to be chapter 13. 13 is never a good number. And on average, you know, it was taking me about a month to write a chapter and then throw it over to my editor or to my co-author for feedback. And then, you know, they'd go in, remove all my jokes, they'd throw it back to me, I'd add them back in. But when I came to chapter 13, I basically blanked and got stuck. And it was on how do you architect a node, right? How do you architect a system? And what I was trying to do is, I had no training material for it. And what I was trying to do was formalize how I went in and architected systems, how I solved customer problems. And that, 7 months in and 70 pages, literally 7 months in, you know, compared to an average of about 1 month per chapter, I ended up giving up and I'm throwing the chapter over to my editor, say, I give up, Andy, I have 70 pages here. This is not a chapter. And Andy, you know, was a really, really experienced and brilliant editor at O'Reilly, Andy Oram. He responds day or night, you know, within half an hour of you emailing him, you've got his response and he's read it over through your 30 pages, 70 pages you've sent him. And his response was, this is not one chapter, Francesco, this is at least 4 chapters. That was his response. And that's when I stopped reading, went in and figured out what are those 4 chapters. And I was writing those 4 chapters in conjunction with a consultancy I was doing in Silicon Valley, where we were implementing the next generation of hard drives and using Erlang to prototype, which, you know, what were very novel ideas, to prove that these ideas work. And then all of the Erlang code would eventually be replaced by assembly or C code for speed. But, it wasn't, speed wasn't the challenge. The challenge was proving that these ideas were working. And so I was working with a lot of hardware engineers, and I was trying to get them to walk through kind of a structured way, and build an architecture before my developers came on board and would go in and start developing everything. And this is where, me writing these 4 chapters in conjunction with, working on this consultancy, I ended up, creating the 10 steps you need to architect a system for scale and distribution. And in fact, these last 4 chapters should themselves have become a book. And because they ended up being about 150, 160 pages. And and I recommend anyone to read them. This is how you should approach architecting any system in Erlang, Elixir, Scala, or for that matter, in any programming language where you're not going down the monolith route, you're actually going down the microservices route. And it took me 1.5 years to write, and the hard part was just abstracting what I did on a day-to-day basis and then describing it in simple terms. Which because every consulting gig is different, and everyone you worked with came with a different background and a different approach. So abstracting it into one size fits all was really, really hard. So I recommend anyone reading it. And yeah, if you can't afford the book, you can find it on BitTorrent, I'm sure. And there are also some really good talks around that, which you can look at, where I cover these 10 steps.
What book was it? Can you please name it again?
Designing for Scalability with Erlang OTP, which I wrote together with Steve Winovsky. So it tells you basically how to architect first a single node using all of these principles Robert described earlier, and then taking that single node and distributing it into a set of microservices and clusters of different systems.
One of the question is, how do you find the Elixir and Erlang community here in India now compared to your last visit?
Unfortunately, I don't know. I see it indirectly because I'm getting more requests on LinkedIn to link to me, but otherwise, I just honestly don't know. I cannot comment.
When I keynoted Functional Conf and we when I keynoted Functional Conf and we also ran the Erlang Factory India, I was really blown away by the community. By the problems everyone was solving and the problems, and how they were using Erlang and Elixir to address things in your local markets. And I was really, really impressed. And I hope, the community has since, been kept on growing and evolving and, continuing doing, what we've done for the last 20 years, which is sharing, inspiring, and giving back, because I think that's how you really grow a community. I think there was another question which was, based on culture, not, companies not wanting to contribute back to open source. What you put in is what you get out. And I really encourage everyone to contribute in terms of sharing knowledge, sharing blog posts, sharing open source, because, based on what you put in, you'll get 10 times more back as a result of it. So, and that's something you need to explain to your managers if they don't allow you to release things as open source, because releasing things as open source means, you've got a lot of more vigilant eyes, the quality becomes much better. And it really helps expand the community, and it makes, and expanding the community addresses another issue which was also covered, which is finding people with the relevant experience. So at the end of the day, you don't want an Erlang or an Elixir programmer. You want a good programmer who can think for themselves, and you need to grow them. They'll pick up Erlang or Elixir in very easily.
Yeah.
So
it's probably more difficult to find, to be honest, finding good programmers. I don't know, but yes, but definitely you want a good programmer, because they will be able to learn whatever they need to learn to do what they're supposed to do.
So how do companies judge, like how do they think who is a good programmer, how to prove a good programmer?
In your opinion?
Yeah.
That's the difficult bit.
Yeah. So I know, looking at the Erlang Solutions kind of recruitment process, where it's someone who has a genuine interest in Erlang, will by default, not by default, but in many cases, I think will have passed the first bar, wanting to work with it. It's realizing what the right tool for the job is, and not being scared of rolling up your sleeves and trying up new things and testing new languages. Being always open-minded, following what's happening out there, and not being too evangelical or really stuck on a particular solution. Someone who comes in and says, "Oh, Erlang is the best thing since sliced bread, and Erlang is a general-purpose programming language, should be used for everything," is not a good programmer, because it's a passionate programmer. It's a passionate programmer, a very passionate, dedicated programmer, but not necessarily someone which, because again, Erlang is not good for everything. So you need to be able to pick, a good programmer is someone who picks the right tool for the job. and tries to address the problems with the best tools out there. And for now, for many of the problems we're solving on a day-to-day basis, Erlang and Elixir are the best tools. There's no doubt about it. But it's not always the right answer. So I think that's my those are the things I look for when I interview someone. I don't know about you, Robert. I mean, you do a lot of interviews as well.
Yeah, it's definitely accepting the fact that there is no one language which is good for everything. I mean, you can do everything in any language. That's not the problem. I mean, people come and say, why should I use Erlang? Because I can write this in C. And perfectly correct. Yes, they can write it in C. But for many things, or at least some things, Erlang will be a better choice than C because it fits what they want to do. But again, as Francesco said, Erlang is not good for everything. And anyone who thinks this, they missed the point somewhere. I mean, if you want to do serious raw numerical calculations, yes, you can do them in Erlang, but yes, they're slow. Right? That's just how it is. In that case,
so you'd contribute to the melting of the ice cap, and we know global warming is a problem. It's not a myth. So yeah, don't use Erlang for that.
Yeah. Take something in Java or Go or whatever, or C, which does this what you want to very efficiently. Then you plug it into Erlang. And let Erlang control it and use that thing in the right language, do that. That's just how you do it. And so, yeah, I think also you can flip that upwards to the company. A good company is one also that will accept that you can't do everything in one language. And everything doesn't have to be done in one language. That can be more difficult, to be honest. Maybe parts of the system should be written in language A and another part should be written in language B, because those languages fit just exactly what they're doing. And then you can combine them. Again, that's going upwards and downwards from the same. I think that's a very, very interesting thing for both sides. And as Francesco said, willing to learn, willing to learn something new and rethink things. Like we've been discussing a lot of times here, the difference between object-oriented program just doesn't fit into the Erlang model. It just doesn't, right? And that's something you have to accept. And then you have to rethink how I do things and use the OO system where it fits, and use the Erlang way of doing where it fits, and then getting to work together. I think that's one feature or one property of a good programmer. They're versatile in that sense.
On that note, actually, I'd be curious to know what your opinions are. I mean, in terms of getting a new employee into your company, I mean, and especially in terms of an engineer, this is definitely something that you want to look at, if whether or not they're good at programming in general. And but in terms of like, let's say growing the community of Erlang and Elixir people in a specific region, because I mean, as Sandesh can attest, it's been a difficult few years just to even get people to come to meetups and join in and contribute and stuff like that. So do you have any tips or any ideas of how one would go about doing that in terms of growing an Erlang Elixir community? Because we've been trying to do that for a couple of years. It's a bit difficult.
Get people to come out, get use cases, get case studies. You will always have companies who need to recruit. Give them the space to showcase what they're doing. Encourage them to release as open source, and think outside of the box, but also invite people from other communities to come in and speak about how they're solving problems. Look at Codebeam, look at the Erlang Factory, look at Erlang conferences in general. We've had Eric Mayer keynote. I think, what is the experiences from C# which we can learn from? We've had Phil Wadler keynote. We've had Simon Peyton-Jones keynote. What are the lessons from Haskell Erlang can learn? Haskell and Erlang were two childhood friends which grew up together. We've had Martin Odersky come in, and jokingly he keynoted when a April spoof blog post came out on how Scala influenced Erlang. So he basically went in and spoke about he renamed it, but he spoke about how Erlang influenced Scala. and and how he did things differently and why he did things differently. We've had Alan Kay come by. We've had there's so many, invite others, invite other communities to come in and interact and have open discussions with them. And openness is critical to it, and then persistence, perseverance. I never thought I'd be here 25 years on after first having used Erlang. As Joe Armstrong told me, something better will come along someday, and I'm keeping my mind open and I'm waiting for the something better to come along. And indeed, it's again, depending on the type of problem, Elixirs come along, and it's better for certain types of problems. Great, so we recommend and use Elixir for that. But for kind of back-end soft real-time systems, I still Erlang is still number one, where maintenance is critical. That's a choice, because your code is so compact and the syntax is so simple. So I think passion, perseverance, and a desire to share, and desire to share and not be possessive and not be possessive, I think is critical to keep on growing the community.
Yeah, I agree to that. Definitely.
I also think doing what Francesco mentioned here, that also opens up more about the interaction between, this case, Erlang and other systems, right? You talk about other systems, and then you get people saying, yes, well, what we're doing, our language or whatever it might be, is good for this, right? It's very good for doing this, and we're doing that, and I think you can open up the interactions and just accept the fact, as I was saying, just accept the fact that one language is not good for everything, and use these, and get people versatile thinking to work out. I mean, I think one of the worst things that can happen, or a bad thing that can happen with Erlang Elixir, is someone uses it for the wrong thing. Like I'm harping on you. Someone does raw numerical calculations in and says, oh, this is a terrible language because it's exceedingly slow at doing this, right? And we'll say, yeah, but you shouldn't have done it like that. Many people will not see it like that. They'll say, this is the view of the language. That it's bad because it can't do numerical calculations fast. Mm-hmm. Just getting into the interactions, getting the versatility, and getting into the conferences, you'll get more people in there, and you'll also get a very lot of interesting talks from other people describing what they're doing, how they're thinking, etc., etc. So yeah.
All right. So there are many remote conferences these years. I think Elixir Conf is also going to be a remote one.
Yeah, as far as I know, it will be. I know
we have I think we all are, sorry, you hear Rice in the background, but all of, I don't think there are going to be any in-person conferences until at least Q2 2021. And I think from our end, the hardest part for our team was planning, and you cannot plan a virtual conference versus an in-person conference. It's two completely different things. So we just took the decision. Let's really make let's take to virtual conferences. And the first in-person conference we're planning again is going to be Elixir Conf EU in April next year in Warsaw. But until then, it's just we couldn't forgive ourselves if we would be spreading the virus, as a result of us being careless at one of our events. It's not something, I would be able to live with, or any of the events team, or in general. So they're going to be virtual. But that said, digital transformation and virtual conferences have opened up the ability to get top speakers.
I think you disappeared, Francesco.
And B, allow audience wouldn't have been able.
Francesco, I believe you're cutting out.
Yeah.
We can't
I can just say for Erlang Solutions, we're going the same way with training. We're just going the same way. We're going the same way with training. I mean, we're not in-person things have been planned at least this year. And
we're
in no way unique about this. I mean, this is the common thing.
No, and we actually have courses scheduled in Indian Standard Time right now, both Erlang and Elixir courses, from what I hear also, which are cheaper than the cost of Indian companies offering similar Elixir courses right now. With the difference that I'm teaching them, Robert's teaching them, and others are teaching them. And we wouldn't have been able to do this had Robert and I had to apply for a visa, get on a plane, come to India. The cost would have been prohibitive. But this allows us to actually provide these courses there, and so it opens up opens it up to a whole new audience, which we wouldn't otherwise be able to reach out to, which is fantastic.
Yeah. So someone asked if we can have link to that course, and also what will be the classroom size? How many students will be there in? This is a really exciting thing.
I don't know. Do
Robert,
we know?
Could you post a link? It's the public training link.
Let's see if I can find it. Yeah. Wait a minute.
Okay. And what do you think about the job market due to this pandemic thing? So companies initially did not want remote employees. Now people are open to remote employees. So how do you think with Erlang and Elixir?
I think more than Erlang and Elixir aside, what the pandemic has done is it has forced through digital transformation, which would have happened anyhow. And I'm currently speaking to you from Italy, where previously I used to come here for 2 weeks, 2.5 weeks in the summer with the family. I get on the odd conference call and do the odd email. I'm now here for 6-7 weeks. Actually, only have I don't have any return tickets back to London. I have friends who've got an office close by, which I'm using, and I'm planning on working remotely for the rest of the summer. So this is really helping with the quality of life, but also it's and it's not specific to Erlang or Elixir. So I think virtual conferences, remote working is here to stay. So there is something which is some positives which are coming out of the pandemic, which we wouldn't have had otherwise.
Okay, so if anyone has a question for in future after this meetup, if anyone has a question for Robert or Francisco, so should we contact you through Elixir forum, or what are the acceptable?
Twitter, please. Twitter.
Yeah, both. I read Elixir. I try to read Elixir forum at least a couple of times a week. So that works well. Twitter goes fine as well.
Twitter works best for me.
Okay.
Hello.
I can email your email. But if you send me email, remember one thing: if I don't answer in a couple of days, resend the message, because things happen. They fall off the edge of the screen.
Yeah, and the same here. I answer my emails bottom up. Last email to come in is the first one I answered, and so as a result, that might not always. The poor person stuck at the top sometimes has to wait. A while, but I will get to it eventually, but not always. So Twitter is much better.
Yes, I remember we had conversations for at least a month for this meetup. Yeah. Emails.
Okay.
Yeah, it was a very busy month as well. So it's
Yeah. So a few more questions are coming in, but it will be much time consuming.
Hi, may I ask a question?
Sure. Sure.
Hi, my name is Nitin. So I read that Beam crashes is, NIF crashes, but if NIF is scheduled by dirty scheduler, how should Beam crash when NIF crashes?
So sorry, can you take that again, please?
Yeah, so I read that Beam would crash if NIF crash, right?
Yes, basically.
Yeah.
Yeah, and we discussed earlier that NIF is, scheduled through dirty scheduler, right? So, I mean, I don't understand, how would, if NIF is scheduled through dirty scheduler and it crashes, how does that lead to Beam crashing?
the thing is that, okay, so when you're running Erlang code, the beam has complete control of what's going on. So there, when Erlang processes crash, the beam detects this and just knows what to do and handles it, like an operating system. If you're running C code, say in an if, then the beam has handed over control to that C code. It does not check it or keep track of it in that sense. So if that C code, then it's just the beam running that C code, just calling the C, literally calling the C function and running it. So if something goes wrong, it's like something going wrong in the beam and it crashes. That's one problem you have with NIFs. And it's like I'm running a normal operating system process running multiple threads, and if one of these threads, the code in that crashes, it crashes down the whole process. That's just how it works, right? That's one of the things you have to think about when you're doing NIFs. Yes, if I run it as a NIF, it'll probably go faster, and the interaction will probably with the Erlang system probably be faster. But it's unsafe in the sense that if my code, my C or Rust code, or whatever it might be, crashes, I'll crash the whole system. It might be better to run in a separate operating system process for that case is safe. Was that what you were after?
Yeah, I think so. So since we are giving up C and we are completely relying on C to make it work, if it crashes, then beam crashes.
Yeah. In that sense, I mean, you have to realize the wrong word. You have to accept that from the operating system point of view, the beam is just any other operating system process. It's me typing the date. From the operating system point of view, the beam is just one big operating system process that runs a long time, but there's no difference between it from that for anything else. It just behaves like its own operating system, managing its own memory, its own process, etc. But from the operating system process, from my Linux or whatever it might be, it's just another program. There's no difference between it. And when you're calling C code in NIFs or LinkedIn drivers, you could do before, it was just calling that C code, that crashes, the whole thing just dies. Right? It's just something to be aware of.
All right. And I think we can have one last question because I mean we don't want to take too much of your time.
Yeah, hi, I'm Neil here.
Hold on, Neil. Just could you give us 1 second? Sure, you can go ahead and ask your question. Hello, Neil.
Yes, are you able to hear me now?
Yeah.
Yeah. So I want to check whether Erlang is a right tool for enterprise service busing architecture. So as it deals a lot with messaging and it's asynchronous, is it a right tool for managing the enterprise service bus? If so, why it was not being so popular?
RabbitMQ is something which is in probably tens of thousands of enterprise infrastructures out there, literally tens of thousands. You know, I think they think there's something like 50,000 RabbitMQ installations out there in the world. At the end of the day, you know, it's you say enterprise message bus. What an enterprise message does is all it does is it switches messages. But if you're switching messages, if you're switching SMSs, if you're switching phone calls, or you're switching IP or ATM packets, you're switching money, you're switching stocks and exchanges, the business logic will be very, very much the same. You know, what's going to differ is how you handle the default tolerance and the reliability and the latency, which will change from one installation to another. But everything else will be the same. So you know, it's definitely one of the key. It's definitely part of the core architecture, especially architectures not written using Erlang itself. Did that answer your question?
Yes. So one more question, just to add on. So is this can be considered similar to a like a JMS kind of things? Because it's a Java service messaging. And AMQ.
So the real so where I see it, where I see RabbitMQ being used in anger is replacing IBM MQ, for example. Or replacing typical rendezvous.
Okay.
So those are the real those are the areas where I see a big difference, and I actually see RabbitMQ competing. I sometimes hear, we're using Kafka instead of RabbitMQ. Anyone who says that doesn't really know what they're talking about, because the use cases between Kafka and RabbitMQ are completely different. And so what I suggest is, and that they might be using it, Kafka for the right tool, but it might be it also might be that they're using it because of hype instead, to get something on their CV, but it's not necessarily the right tool for the job.
Okay.
Hope that helps. By the way, anyone who's in Umbria, Italy, and is hungry, you're very welcome to come by for lunch. There's a vegetarian 4-cheese risotto on the menu right here, which I am cooking right now as I'm going along, because I've got children who will otherwise jump up and down. But yeah, suitable for vegetarians, not vegans.
That sounds delicious. But I mean, if only we were there to have some of that.
The last question was the one which Robert has answered in chat. Would you like to take it in here? The question, Robert, which answered?
About gen server state?
Yeah, right.
Yeah, okay, so the reason, of course, is that when a process dies, everything about that process goes away. Nothing, the system saves nothing when a process dies. So if that process, whether it's the gen server or whatever it might be, has state which you want to save in such a way that when the process dies, it can be reused by another process coming up, you have to explicitly save it in some way. Okay, that's just the way it is. That there's no way around this. Now you can
that is the way that is the way you want it as well, because if the gen server crashed, it crashed for one of two reasons: either your state was corrupt, or you've got a bug in your code. So what you do hope is that your state was corrupt. So by crashing the gen server and then restarting it, you go in and you recreate the state from the ultimate source of truth and not the copy you have in your process. And that, in many cases, will actually solve the problem.
Yeah. 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 So it's something you have to work with and think about. From that point of view, the base Erlang system is extremely simple. Everything goes away. I have to work out, when do I want to save things? How do I want to save it? I mean, we're mentioning ETS. ETS is fantastic, but ETS is in RAM memory. So if your machine dies, then it's all gone, right? So if I want to save something even longer, then I have to save it on disk, and I have to do that explicitly, work out what to do, et cetera, and when to do it and how much. What am I willing to pay for this reliability? Again, it's what do I get? What does it cost me? Type thing. I have to work this out.
And this, every layer has every layer. See the whole kind of error handling and recovery strategy in Erlang and Elixir as an onion, where you've got different layers. On the first layer, you've got the sequential error handling, which you use through try-catch, where you try to basically catch a sequential error and recover from it. If you fail, you raise it and you restart your process, hopefully recreating the state. If that doesn't work, you restart your whole supervision tree. If that doesn't work, you restart your node. If that doesn't work, you restart your container. If that doesn't work, you actually reboot the machine, and you keep on escalating in the hope that you're going to solve the problem. And obviously, every escalation will become more expensive and affect the system much more. But it's just different levels of isolation. And ideally, you focus not on handling the error when it happens, but you actually focus on on the recovery strategy of it.
Yeah, I've talked to developers who say they've never thought as much about errors as when building Erlang systems.
Yeah,
because it's up front. You're thinking about what happens when this goes wrong. How am I going to handle this? When do I do this, etc. And this goes very much into the structure of your system. So you're thinking up front. Again, what is a supervisor? Well, it is something that's there to handle the case the process dies. So while I put a supervisor there, I'm thinking about what happens when this process dies. What do I want to do? Well, I could just let it crash. Maybe it's fine. Maybe it just needs to be cleaned up and died. Maybe I need to restart it. And I have to think about all these things on designing the architecture of my system. And what Francesco was saying, then we go another layer out. What happens when this dies? Well, then I'm thinking about a larger system where this is a part of it. And what do I do when things go wrong, et cetera, et cetera, et cetera. So it's very much thinking about what is to happen when things go wrong. So when they go wrong, the system can handle it at the right level for it. There's a lot of planning up ahead. And that, I think, is one big difference from doing in many other systems where you're just returning error values. You have to try and handle it everywhere and get something out of that. Trying to get some sense from it. But here, a lot more, it's just the whole architecture, not just the Erlang architecture, the OTP architecture, the layers on top, et cetera, et cetera. We're doing these things for it. And you're typically used to doing it, but maybe not at the lower levels. So, yeah.
Yeah. Okay. I think we had really great questions. And if anyone has more questions, they will tweet you.
Yeah.
I'm really thankful. Yes, please continue.
No, go ahead. Sorry, go ahead. Yeah.
Yeah. I'm really thankful, Francisco, for accepting the invite, and also thankful to Robert for accepting the invite last moment. Yeah. And
no worries. I thought it was fun. I've enjoyed myself. So yes,
yeah.
and hopefully we're going to answer.
Yeah.
Questions people have.
Like I had a discussion with Robert.
Yeah. Sorry, just to say, go ahead. Sorry, Sanish. It's the latency here. Go ahead. Okay.
So I had a word with Robert in 3 years back, 2017, at Functional Conf, and I mentioned him. We will invite you someday for our meetup. And yes, the day is today. It took some time.
Yeah.
So
yeah, that's great. That's good. Yeah, I've been to 2 functional conferences, conferences, and I've enjoyed both of them. So yes, and now.
Okay, yeah. Maybe we can do one more remotely this year, maybe, and I will mail you about it.
Yes, if I can, I'm on. Right.
Absolutely, and yeah, I mean, speak to Naresh as well. He's absolutely brilliant and really, wants to build community as well. So it's I love Functional Conf India. Really enjoyed it, and and I enjoyed just being there. We were talking actually about our trip to India last night, and hopefully there'll be other opportunities. One thing, one regret I have I really enjoyed today as well, and apologies for me cooking in the background, but it's I think Italians and Indians, I think we're both known for not kind of sticking to time, and I think we're 1 hour over right now. But I think one regret, next time we've got to get Mike Williams on board as well. So the further co-inventor as well, and I think I don't know why we didn't think about asking him, but I'm sure he would have loved to be on it as well. So it's definitely something to think about next time.
Sure. And he would have presented a completely different set of views and opinions.
Oh, absolutely.
We all
and if we would have argued,
yeah, he was wrong, of course, but that's another thing. If you ask him, he'll say I was wrong.
So we can plan something in November or December for the next meetup.
Sounds great. Yeah.
Okay.
Good.
So that was thanks.
I'll try and get another poster on the wall in that case.
So we cannot take a group picture, someone asked. So let's have a group picture by please take a screenshot by clicking on.
Yeah, I don't know how that works.
Yeah, if all can turn on their cameras, we can take a screenshot and conclude.
Let's see what happens if we go full screen. Can you get everyone on there? That's the problem.
Yeah.
It doesn't like that.
Can you see me here?
It's like a maximum.
Yeah.
I'm actually standing behind an Indian tapestry we bought in Baipur, in Kerala, right now.
Oh.
Yeah, from the Tasara weavers in India. So I think it's perfect. Yeah.
So please, all please take screenshots and do tweet and tag Elixir Pune, Elixir India in your tweets.
Yeah. Perfect. Brilliant.
Yeah. Thanks, guys. This has been a real treat.
Yeah. Thank you. Have a great weekend.
Thank you.
Thank you.
So we are closing.
Have a great weekend, everyone. Thank you. Bye-bye.
We enjoyed.
Bye.
Bye.
All right, guys.
Thank you, guys. Bye.